Okay, so based on the equation that we had just now, the average power is only contributed by the fundamental components, and also the fifth components of voltage and current. So therefore, the average power can be found by using that equation 9 here, which is the amplitude of 1.2, the fundamental of voltage, multiplied by 0.6 divided by 2, and the cos angle between the voltage and current, which is 30 degree. And then we also have the power contributed by the fifth component, which is 0.2 voltage amplitude multiplied by 0.1 current amplitude divided by 2, and cos 45 degrees, which is the angle between the voltage and the current. And therefore, if you solve that, you will get that the average power equals to 0.32. Okay, so that is all about the instantaneous average power. But now we try to look at the one examples for these type of problems. Okay, remember, you also can be given look at this question 4 problems. The analysis of the current and the voltage at the supply terminals to a control rectifier load gave the following phase values. Okay, so the while doing that AC to DC, the control rectifier, when you look at the voltage input side, we have the current is given in terms of AN, and BN, whilst the voltage is given in terms of Cn. Look at that, we have a Cn and sine omega t, but for the current it is given by in terms of Bn and An. Okay, so don't get confused yourself. To solve this, you need to convert whatever current or either current or voltage which are given in terms of AN and BN. You need to convert them into equivalent Cn. Okay, the coefficient of N, Cn, coefficient of C, Cn. Okay, for example, in this case, you need, before you solve for the power, the average power, for harmonic distortion, and the rest, you need to convert the current series into the Cn, right? So this questions requires you to convert that into Cn, and then you have to identify, extract the information from the voltage given, right? And you need to determine the net power delivered to the load, or the total average power delivered to the load. You need to determine the current harmonic distortion factor, and also determine the overall power factor. Okay, so let's go straight to the solution. Right, so this is equation that is given to you. So there is no should be a naught over 2. There are divided by 2 missing from the equation, right? So for this case, we don't have that a naught and v naught here. Yeah, this term is 0, but you are given in terms of an cos and bn sine omega t, and for the voltage you are given in terms of cn sine and omega t with the angle, and cn is of course known, can be found by using this equation, which is the square root of an squared plus bn squared, and the angle can be given by inverse tangent of an bn. Right, so solve for the voltage. We do have that voltage, the fundamental voltage, 340 volt, and for the current, A1 is 80.4. Okay. No, if you compare with the, sorry, that 80.4 is actually your Bn. Yeah? That 80.4 is Bn, and minus 40 is actually your Cn, An. Yeah? This is your An. The 40 minus 40 is An. 80.4 is your Bn. So there's a bit of mistake in your notes. Please make a corrections. So this should be B1 and this should be A1, right? So you solve that. However, you still get the same question here, solution here. You have C1 equals to 89.80, and then if you yes, the inverse tangent, the actual equation is An over Bn, so there's a mistake here, so this equation is correct. So the angle is minus 26.5, right? So therefore your I1 equals to 89.8 with the angle of 26.5, and then you move on to find the, according to the solution, you find the power for fundamental components, which is V1 over square root 2 and I1 square root 2, or you can apply straight using the equation V1 I1 divided by 2, and then cos the angle between theta V and also the theta I. Yeah? So that gives you the fundamental power. Power that contributed by the fundamental component is 13.67 kilovolt, and we know that the this component, this voltage and current, the power is only delivered by the first components, the fifth and the seventh. Oh, so all harmonics actually contribute to the average power, because both voltage and current has the same harmonics components, harmonic numbers. So you need to calculate for V1, and then you proceed with the fifth harmonics. You do the same. You get the already the Cn for the voltage, so it's 11 volt, but the angle is minus 70.2 degree. And look at the for the current, is it true? Look at the equation again. So for current, 10.5 is your An, 19.2 is your Bn. Okay, so 10.5 is your An. Again, this is also a wrong solution, notations here. So the coefficient of A5 is actually 10.5, and the coefficient for B5 is 19.2. However, the angle is correct because you have the angle is inverse tangent B1 B5 of 10, so this gives you the correct angles at 28.7, and I5 equals to 21.9. Right, so again, this is the power contributed by the fifth components of voltage and current. So you get minus, remember, instead of plus, you also can have, we can also have a minus 18.6 watt. And finally, for the seventh harmonic, you have that 18 volt with the angle of minus 110 degree. Let's look at the seventh harmonics. Is it right? So if you refer back to the seven harmonics, 4 is your An, A is 7, 11.4 is the B7. So let's go back to four is for An. Again, this is again the solution here is not really correct, but I hope you get the way look at how this can be in terms of how you can solve this type of problems. Okay, so again, An should be 4, B7 should be 11.4, A7 should be minus 4. So for that, you get the I7 equals to 12.1, and you have the degree. Angle for 7 is 90.3, so for that you get minus 2.4. So therefore the total power delivered through the load is given by P1 plus P5 plus P7. So you have 13.67, if I'm not mistaken, kilowatt minus 18.6 watt and minus 2.4 watt, and finally the total power delivered to is 13.65 kilowatt. So yes, you can calculate the total harmonic distortion. This is came from the first topic where we discussed about the rectifier. We have the equation for the total harmonic distortion, calculation for the equation for that. You use whatever information is given to you. So this is I5. Make sure that you get the everything's correct, the information. This is in terms of RMS. So if you given in terms of amplitude, you have to make sure that you convert that into RMS first. And finally, you have the overall power factor. So of course you need to calculate for the VRMS, use this equation, and then the IRMS, and use these equations, right? So you get the VRMS and IRMS total RMS of the voltage and current. And then from the general equation that we have, which is the P total equals to VRMS IRMS multiplied by the power factor. So from that, from the solution just now, from the answer just now, on the total power and also the VRMS and RMS, we can determine the overall power factor, which is 0.86. So I hope